Okay, let's begin our Math 1316 study of trigonometry. We're starting with Chapter 1, Section 1, and this is on angles. What we'll be doing is doing some review in Chapter 1. Of geometry mainly, and that's to have vocabulary clarity, and some algebra for computation, recall, on how to approach problem solving. And our first idea is, do you see angles in the pictures? And of course, you should say, yeah, kinda, sorta. Well, we see this angle here, this angle here. Now, I'm not showing all angles, but there are spans of angles. This is a straight angle. And that's what we'll be studying, recognition of type and size. So let's first look at our line. A line has no beginning and no end point. It is denoted by some name, and above it you'll see a line with two arrows. A segment is different. A segment has a starting point and an ending point. Therefore, it is measurable. And we use it a lot to create shapes in geometry as well. And that notation is a line over it. Then we have an important one, is the ray. The ray has a starting point and a directional line. So we see that a ray AB can be written as this, showing direction. Now, why did we need that background? Because you're saying, I know that. Well, of course you do. It's because an angle is created by two rays starting at the same point. And going in different directions. So if I have a ray here and I have a ray here, well, this creates this angle here. So we need to understand about references to how to measure an angle. So we have the initial side, So the ray that from which we measure the angle is called the initial side. So if I have this angle here, I'm making this my initial side. Then we have the terminal side. So I could have my angle go like this, and this is my terminal side. And you're saying, well, how do you know? Well, there's another little notation of this side, a circular arrow showing initial side to terminal side. And then the most important part is the vertex. The point shared by both rays. So there you have it. Okay, just vocabulary, just vocabulary. So now we're talking about degree measurements. And degrees are very interesting. They go from 0 degrees to 360 degrees, creates one circle. So we have, this is our initial side, and then our angle is going in this direction. And if I go over here, then this is the terminal side. And this is my vertex. But it can be measured in this fashion, or if I make the opposite happen, it could be measured in this angle section. So it depends how it's written. And we say that 360 degrees equals 1 revolution. You can have angles that are more than 360, which just implies the fact that you're rotating several times. All right, so now we come to types of angles. Types of angles. In types of angles, we have acute angles, and they are greater than 0 degrees, which means no angle at all, but less than 90 degrees. So they're acute, and so very smaller angles. Then we have the 90 degrees, and we'll be studying this one a lot, and that is our right triangle angle, and it is exactly 90 degrees. It has a square inclusion that denotes 90 degrees. Very important. If you don't see this guy, if you don't see it, then it's not considered 90 degrees. Then we have obtuse. And obtuse says it is greater than 90 degrees, but less than 180 degrees. And then we have the straight angle. Exactly 180 degree measurement and it is called a straight line. It creates a straight line. So now we're talking our algebra component. So complement angles, and you've had this all of your studies somewhere in your studies in high school or in whatever prep school you've been. Complement angles are the sum of two or more angles who create a 90-degree angle. So having this knowledge, we can then figure out by algebra to solve for size of angles or by subtraction. In our cases, we're going to review algebra though. And this means the following. So I have a drawing. I have my 90-degree notation. So I know the two angles create a right triangle. A right angle, I should say. Sorry about that. And that means that I have 5x plus 5, this is angle 1, plus 3x plus 5, angle 2, must equal 90 degrees. Well, now I'm going to remove the parentheses, and I'm going to have the 5x plus 5 plus 3x plus 5 equals 90 degrees. Now I'm going to combine like terms. And in this case, it's going to be my x's and my constants. So let's do some math. 5x and 3x is 8x, and 5 plus 5 is 10. Then I do additive inverse. To isolate or put alone the variable. So this means I'm going to subtract 10, and what I do to one side I must do to the other. And I'm going to do the math. That means that I'm left with 8x is equal to 80. Then I undo multiplication by dividing. So in this case, I'm going to divide both sides by 8. I hope I don't confuse you. A fraction bar means to divide. So when I do that, I have x is equal to 10. Well, this does not give me the value of the angle. Only the value of x. So now, step 2 is, because this was step 1, and now step 2 is find the measure of the angles. Okay, so we have 5x plus 5, and we know that x is 10, so that makes it 55 degrees. Then we have this is angle 1. Angle 2 has 3x plus 5. And that means I have 3 times 10 plus 5 is 35. Now, if I add those up, I get 90 degrees. Okay, nothing difficult. Now remember, these are the solutions. So we've answered the problem. Good. Let's do one more. And you're saying, oh, this is easy. I'm going to make 100. And you sure are. Yes, you are. So here we go. So here the angles are in a different position, but the first thing we notice is it is a right triangle. Therefore, the sum of the two angles equal 90 degrees, and they are complementary angles. Okay, so first thing is find the value of x. All right, so I have 2x plus 4x has to equal 90 degrees. This one's easy, isn't it? Yeah. 6x has to equal 90 degrees. I'm going to divide by 6. And that will go 1, and 30 is 15 degrees. This is only the value of x. So our second step is to find the angle measurements. So that means that I have the 2x, and I know x is 15. 2 times 15 gives me 30 degrees. And then I have 4x. And that means 4 times the 15, and that equals 60 degrees. If I add them up, I get 90 degrees. Yet this is the angle measurement. Of the complementary angles. Great. All right. Well, we've had 2 with pictures, and I love pictures because you want to make sure you can visualize the action. Mostly, though, in mathematics, we use language. So here we have complementary angles, which means we have sum is 90 degrees of the measure of 9x plus 6 and 3x. So we have our 2 angles. So now I'm going to say 9x plus 6 plus that 3x must equal 90 degrees. I'm going to combine like terms, which are these guys. 12x plus 6 equals the 90 degrees. Sorry, made a little room. I'm going to do the additive inverse. So that gives me 12x equals 284. I'm going to divide by 12 so that x is, and if we do the math, what is that? It's 6, isn't it? No, it's 7. 7. So now we did the first part. Our second part is to find the angle values. Our first one was 9x plus 6. That gives me 9 times 7 plus 6. 63 plus 6 looks like 69 degrees. My second angle is 3 times x. So it's 3 times 7, 21 degrees. If I add them up, I get 90 degrees, and that is true. Is everybody comfortable? All right. Anything difficult, stop the video and look at it again. I'm trying not to go fast because that's a tendency of mine. Supplement angles. 2 or more angles whose sum is 180 degrees. They create a straight line. So we're using the same principle as above. Where we construct the equation, where we know that angle 1 plus angle 2 must equal now 180 degrees. So we're starting easy. So our first step, find the value of x. So I have 7x is one angle, plus 11x is the other angle, equals 180 degrees. This is 18x as I combine like terms. Now I'm going to undo multiplication by division, and by now you're used to me. So x is 10. Our second part is find the values of the angles. So I've got 7x is one angle, and that gives me 7 times 10, 70 degrees. Then the other one is 11x, which gives me 11 times 10, which equals 110 degrees. When I add them up, I have 180 degrees. Now you can see that the algebra is simple. Nobody's panicking. Well, of course, we're going to have another example. Here we have constants attached to the angles. We have angle 1, and we have angle 2, and they create a straight angle. So we know these are supplementary angles. So we can use our formula here. So I'm going to say we're going to solve for x. And we have 20x plus 10 is angle 1, plus 3x plus 9 as angle 2. They're supplementary, so they equal 180 degrees. 20x and 3x is 23x, plus 19 equals 180 degrees. I'm going to subtract the 19 from both sides, additive inverse, and that gives me 23x equal to, I have to do some math here, let me see, 161, right? 10, 8, yes, 161. I'm going to divide by the 23, and you're welcome to use a calculator, which I'm going to do the same thing. Actually, I'm not, because that's 7, isn't it? 7 would make 21, 14, 15, 16, yes. Well, that answers part of the problem. Now we're going to have to do step 2, which is find the measure of the supplementary angles. So that means that I have 20x plus 10. So that's 20 times 7 plus 10. And that would make it 140 plus 10 equals 150 degrees. Then I have 3x plus 9. 3 times 7 plus 9. 21 plus 9 equals, that's a 9, 30 degrees. And then, of course, that gives me 180 degrees. All right, questions? Again, if there's some mathematical aspect of this that I have not covered, by all means, play it again. Now we're going to have language. The key word here is supplementary angles. If they're supplementary, therefore they total 180 degrees. And my angles are 6x minus 4 and 8x minus 12. A little different from what we've done, but definitely not anything we can't handle. So our first step, find the value of x for these supplementary angles. Let me make some room. I'll write kind of big. So I'm going to have the 6x minus the 4 plus the 8x minus the 12 equal to 180 degrees. I'm going to combine like terms, so I have 6 and 8 is 14x. Minus, because those are two negatives, I add and keep the sign. So I'm going to have a negative 16 is equal to 180 degrees. I'm going to add the 16 because the additive inverse is a positive. This gives me 14x equal to 196. Now I'm going to divide by 14. Now I'm going to use my calculator and do the 196 divided by the 14. Make sure I don't make an arithmetic error for you. X equals 14. So that's step 1. So now we're going to do the second part. Find the measure. Of the supplementary angles. All right, so remember our first one was 6x minus 4. So that's 6 times 14 minus 4. Let's do that on the calculator so I'm not embarrassed. 6 times the 14 minus the 4. And I get 80. Then my second angle is 8x minus 12. All right. So that's 8 times the 14 minus 12. Okay. I get 100. So these two added is definitely 180 degrees, which means we have supplementary angles. Okay. Now this next section has to do with subdivisions of degrees, minutes, and seconds. So in this, we understand that a degree has a number followed by an upward 0. Seconds have a number with a hyphen after it, and seconds have a number with quote signs after it. So degrees we understand, those are complete digital numbers. Seconds, we understand that 60 seconds equal 1 degree. And then we have, just like in time, we have minutes and seconds. Well, 60 minutes equal 60 seconds, sorry. I got those confused for you. Let me start again. I apologize so much. There we go. 60 minutes, like an hour, equal 1 degree. 60 seconds, like time, equal 1 minute. And seconds is the 2 hyphens. Now, I've inserted at this point something I found on the internet explaining latitude in regards to the equator, and it's minutes, and it's measured in degrees, minutes, and seconds. And so this was just something that I put in so that you could read and understand for future reference. Now, I'm not going to read it to you, but you're welcome to do so. It's pretty interesting how it happens, and you always hear of latitude and longitude, and we'll be covering that in some word problems later on. So here I have it broken down again. And it's the angle measurements as uniform amounts for 360 degrees. Is one complete rotation. And we have this notation, the little zero above the number. Minute, like in time, 60 minutes. And that's that 1 hyphen equals 1 degree. And like in time, also, 60 seconds, and that's a double, equal 1 minute. So in doing this, we have to look at the conversion of some of the processes into a succinct form, understanding that process. So here I have 62 degrees and 18 minutes, and I'm adding to it 32 degrees and 52 minutes. So here I can add any way I want. 94 degrees, 10, carry the 1 is 70 minutes. The problem is this is can change can be converted to degrees and minutes. So here we go. We're going to do just that. We understand that 1 degree is equal to 60 minutes. So now what I have is 95 degrees and 10 minutes. And we have reduced to lowest terms by definition. And you may do it any way you please. So we have another example here. We have 97 degrees and 42 minutes, and we're adding to it 81 degrees and 37 minutes. I'm going to add, and if I've made an error, I apologize, but I don't think so yet. And then I say, ooh, this is over a degree. So I'm going to subtract 60 minutes and make 1 degree. And that gives me 179 degrees and 19 minutes. Well, as you can see, there's very little math. It's primarily clear. Here is subtraction. And now we have to remember that conversion rate. I have 71 degrees, 18 minutes, and I'm subtracting 47 degrees and 48 minutes. Well, I have to start in the lowest unit of measurement, and this would be on the left. and I have to borrow. One degree equals 60 minutes. So I'm going to come over here, and I'm going to make this 70, and this 60. All right. So when I do that, I'm going to get 70 degrees and 78 minutes minus the 47 degrees, 48 minutes. Now I can subtract 0, 2, 3, sorry. And then I will do 3 here and 2. So this is my difference. All right, so we have another example here. 90 degrees minus 17 degrees and 13 minutes. Now this one's easier because I'm going to borrow one from here. That makes it 89 degrees, and of course this becomes 60 minutes. Now I can do the subtraction. And this is my difference. All right. Now, this is our first exposure to calculator, okay? And I've typed it out, and I would like you to write these notes to utilize technology. Because I required the TI 83 or TI 84, if you have an Inspire, you have to use your menu bar to find what I'm talking about in the trig section, and you'll Google that if you need to. Converting degrees, minutes, seconds to decimal approximations. So in this case, we're converting into a measurement. So the first item is to enter the degree value, then hit second apps on your calculator. The second gives, on top of apps, you'll find the word angle, and choose number 1, which gives you the degree notation. Then enter the seconds value, and then do second apps, choose number 2, which is the hyphen for seconds notation. Enter minutes value, then you do the alpha, that's the green key, and the plus, and that gives you the quote notation. Enter, and then around the answer, to decimal place value needed. Now I'm going to work it both ways. I'm going to also use, I'm going to demonstrate conversion by identity given above, so that you can get the full impact. But to be honest, you don't need too much of that in personal knowledge. Now make sure you copy down all the steps and have them in some paper or some identified as calculator entry. So here we are. I've got this guy right here. And I happen to know that this is 274 degrees plus 18 minutes plus 59 seconds. So if I was to do it by hand, I would have the 274 plus 18 parts of 60 plus 59 parts out of 60 times 60, because 60 seconds equal a minute and 60 minutes equal a degree. So that's how the structure would be. And then I would use the calculator to figure out what the decimal is. So let's do this one first. And we're going to do the calculator as well. All right, so here we go with a calculator. Let me clear off what I have. And I'm going to do the 274 degrees added to 18 divided by the 60 added to the 59 divided by the 3600 and enter. And I get this number. Let me 274 3163889, blah blah blah. And we would do it to 3 decimal places, so we would say it's that many degrees in a decimal. Now we're going to do it by calculator. 274 second apps, and I'm going to hit 1, enter. Then I'm going to enter the 18 second apps, and I'm going to do number 2. There's my second. Then I'm going to enter the 59 alpha plus, and then I'm going to hit enter. I got the identical thing. Does everybody see that? Is everybody comfortable? The calculator is very good, but it's only as good as you take notes. So remember, I post the notes, so if you didn't have time to write everything, you will in this next group. Okay, let's do the next one. 165 degrees plus the 51 degrees, sorry, that's your instructor making a mess. And 9 seconds. All right, so that would be the 165 plus the 51 parts out of 60 plus the 9 parts out of 60 times 60. 165 plus 5160 plus 9 over 3600. All right, let's do our calculator. 165 plus 51 parts of 60 plus 9 parts of 3,600 in, and I get this number, 165.8525. So if I'm doing 3, I'm going to have 165.853 degrees. All right, now we're going to do it with a calculator. 165 second apps 1. And then we'll do 51 second apps 2. Then we're going to do 9 alpha plus, and then enter. Did I get the same thing? Yes. Okay. Very good. All right. So let's go to the most important part here is our quadrantals. Our quadrantals are very, very important. It is the exposure, to angles on a coordinate grid. And what we have to understand is the position of those angles on a coordinate grid so we can prepare for trig. And we understand that in the coordinate grid, if we start at this position, we have 0 degrees. The first right angle is 90 degrees. The next is a straight angle of 180 degrees, which is at the x-axis, so 0 to 180 is a straight angle. And then our next one is 270 degrees, which is all the way to the y negative axis. And it is 90 degrees from the 180, and then we end up with 1 revolution at 360. So if we're looking at an angle and we said 360, it's the same as a 0 degree. And those are important aspects. So what do we have? 0, a start. Then we have a right angle at 90 degrees. 180, a straight angle. 270 is 90 degrees from 180 to 70. And then 360, we come right back to that terminal part, one complete rotation. So this brings about coterminal angles. And coterminal angles are references. So we have to discuss that, and what the coterminal angles are angles that represent the same angle from a different direction. In the case, and we understand that we can go several times over and get the same thing. So here we have direction marks. So a standard angle is measured from 0, then moving counterclockwise. A negative angle is measured from 0 in a clockwise fashion. All right, so let's look at this. Now here we have how to mention 60 degrees with multiple fashions. Now think about a 60 degree. All right, so let's assume that I drew this perfect. This is 60 degrees. and this is going in this fashion. Well, I could go 360 and again and go right here, and that would give me that 780 degrees because I've moved that many times around. Whereas if I went in the reverse direction, if I started here at 0 and I went in the reverse, I would have negative 300 degrees. Okay, so those are ways of getting the angles. Now, we're given this example. Find the angle of the least positive measure. That means that we're not going in the reverse angle. Not equal to the given measure that is coterminal with the A. So we have, in this case, let's just make an approximation. It's a negative 52 right here. So so what we need is to go from 0 in this counterclockwise to get the positive. So we would take the 360 degrees and add to it the negative 52 degrees, sorry. And that would give us 308 as the smallest positive angle. Because anything else, I would have to add 360 to it. All right, so let's do another one. Okay, so here we have 83 degrees, and it's in a standard. And it says in degrees not equal to the given angle. Well, 83 is approximately right here, and that is in its form. So that means the only thing I can do is go in one more revolution to get to the same angle. So that would mean I would take my 83 degrees and add 360, and this is the smallest positive angle to 83 that we can give it. So this would be that answer. Now this one says 443. Well, that is what I have right here, right? If I did the math right, right. So this means that I've gone this many to get right there. So this is greater than 360. So to find the smallest, I would subtract 360 degrees. So that would be the 443 minus the 360, 83 degrees. There you have it, coterminal. All right, this is our last problem. I know you're exhausted. A tire is rotating 600 times per minute. So we're going to write this ratio. 600 rotations per 1 minute. Through how many degrees does the point of the edge of the tire move in a half second? Well, we've got it rotations per minute, and we know one rotation equals 360 degrees. All right, so we can do it all kinds of ways. We can first change it to seconds. So we know that 1 minute equals 60 seconds. Now that will cancel the minutes, and I got seconds. But I don't need 60 seconds, do I? I need a half a second. So this will give me rotations per second first. Let's do that math first. So if I do this math, I'm going to have 600 rotations per 60 seconds. If I divide by that 60, so I get 10 rotations per 1 second. But I need a half a second, so I'm going to divide by 2. So that'll give me 5 rotations per 1/2 second. Now, I know that 1 rotation equals 360 degrees, if we want to know degrees. All right, so now what I've done is canceled rotations, and I have degrees per half a second. All right, does everybody see that? So I'm going to multiply 5 times the 360 and get 1,800 degrees in 1/2 of a second. And we're done. Okay, a lot of material. Thank you for listening. It's very important that you do the homework. So take good notes. Keep a calculator instruction sheet. And 3, do homework as quickly as possible. Thank you for listening.